Everyone, let us continue with the next part of this lecture, which is 3.2 binomial expansion. So binomial expansion is only focusing on the positive integer, which is n equal to 1, 2, 3 and so on. So let's us recall what we do during our high school. So let's say we have a expression of a plus b all to the power of 1. So we just have to multiply for one time, so we don't have to do anything. It will be a plus b. And then a plus b squared. So this is an equation of quadratic, right? So what we should do is to expand for two times. So a multiplied by a, b multiplied by a multiplied by b, and b multiplied by b. So what we will have is a quadratic a squared plus 2ab plus b squared. And then the third one is if we have a power of 3. So we have to expand for the third time, right? So it will be, so the result will be 8 power of 3 plus 3 a squared b plus 3 ab squared plus b cubed. And then the fourth one, we have to expand the fourth one and so on. So do you want to expand every time you want to find the expansion of power of n here? No. That's why we have this binomial expansion. So expansion of a plus b to the power of n. So there are two methods to find the expansion of this. The first one is by using the Pascal triangle. So this is done by Mr. Pascal. And then for this expansion, there are some properties that we can see as we read from left to the right. So the first property is there will be n plus 1 terms with n begins with the a to the power of n and ends with b to the power of n. And then the second property is that the coefficient of the first two terms are 1 and n. And then the power of a decrease by 1 means that it will start from n and then the last term should be power of 0. And then the power of b, however, will increase by 1, which means that it will start with 0, power of 0, and then the last one should be power of n. So the opposite of each other lah. And the sum of the power of each term is the same as the power of n. Means that a power of a is the complement of power of b. So this one will be n minus n complement. So n minus n. Okay. And then for Pascal triangle, the coefficient of the expansion can be arranged in a triangular array of number that we call as Pascal's triangle. And the coefficient of each row are symmetrical, and each row begins and ends with 1. So let's see the Pascal triangle. Okay, this is our Pascal triangle. So we start with 1, where a plus b to the power of 0. So any number to the power of 0 will be 1. And then the second step is a plus b to the power of 1. And then this one is the coefficient for a. And then this one also coefficient for b. And then the next step is 1, 2, 1. So we add up with the left side and the right side of the value to get the next step. So this side we don't have any value, so we assume it's 0. So the right is 1. So 1 plus 0 is 1. And then for the middle part, it is 1 plus 1. Why? We add up the left side of the number and the right side of the number. And then for this one also we get 1. So it should be symmetrical. So that's why we have 1, 2, 1 here. So this is for a plus b squared. So what is the result for a plus b squared? A squared plus 2ab plus b squared. So the coefficient is 1, 2, 1. So we continue up to the next levels. Okay, so do you want to find for the a to the power of 7, a to the power of 8, a plus b to the power of 8? So will be a hassle because we need to do all the steps first to get that level. For example, we have the fifth line of Pascal triangle here, which is 1, 5, 10, 10, 5, 1. 6 term, so n plus 1 terms. And then this is for a plus b to the power of 5. So we have 1 as the coefficient, and then a have the power of 5. So the power will be decreasing accordingly. So we have a power of 5 here, and then continue with power of 4, 3, 2, 1, and 0. And then for b, however, we have a power of 0 and will increase. So it will be from 0 to 1, 2, 3, 4, and 5. Okay, we just have to put the coefficient accordingly. So the result is a to the power of 5 plus 5 multiplied with a to the power of 4b plus 10 a to the power of 3b squared plus 10a squared b cubed plus 5ab to the power of 4 plus b to the power of 5. The second method to find the binomial expression is to find the binomial expansion by using the binomial expansion. So Pascal triangle is only helpful for finding the coefficient of the term in the expansion with small value of n. Because if you want to find the larger value, we need to do from scratch. Means that we have to start from the top one. So for large value of n, we use the general formula of binomial coefficient, which is it is equivalent to n choose r. So it is this formula involve the factorial notations. So what is n choose r? It is equal to n factorial divided with r factorial multiplied with n minus r factorial. So you have this notation in your calculator. You can just directly or use NCR directly. So the formula for any positive integer n, a plus b all to the power of n will be n choose 0, a to the power of n, b to the power of 0, and then we add up 1 for the value of r, and then a will have a power decrease by 1, and b have a power increase by 1. And the last term should be n choose n, with a to the power of 0, b to the power of n. First term, second term, nth term, and let's do some example. Example 6. By using binomial expansion, expand 1 minus 2x all to the power of 4. How to solve this one? So we have to recognize what is our a first, and then b, and then what is the value of n. So for this question, what is our a? So a is the first term here, which is equal to 1. How about b? Yes, we have to take the negative sign because the formula is only for a plus b. So we need to determine what is our b. So our b here is negative 2x. And then how about n? Yes, we have 4 as n. So what we need to do is just substitute into the binomial formula, binomial expansion coefficient. So we have 4 choose 0 for the first term with a, our 1, to the power of n, which is 4. And then b, negative 2x to the power of 0. So the second term, it should be, we add up with 4 choose 1. So 1 to the power of decrease. So 4 will be 3, and then our b, negative 2x, from 0 will be 1. So continue with the third terms. So third term, 4 choose 2 of 1 square multiplied with negative 2x square. And then the fourth term, 4 choose 3, 1 power of 1 decreasing, and then negative 2x power of 3 increasing. And then the last term should be 4 choose 4, 1, 0, and then the b should be the power of n, which is 4. So count the number of terms here. So because we have n equal to 4, the number of terms should be 5. So 1, 2, 3, 4, 5. So complete terms here. So simplify everything. So we should have the result equal to 1 minus 8x plus 24x squared minus 32x cubed plus 16x to the power of 4. Don't forget to simplify every term. So this one, 4 choose 0 is 1. 1 to the power of 4 is 1. 1 multiplied by 1 is 1. And then negative 2 to the power of 0 is 1. For this term, second term, 4 choose 1 is 4. So 1 to the power of 3 is 1, but negative 2 to the power of 1 is negative 2. That's why we have negative 8 here. So please simplify everything before you solve it. Okay, what is definition of n factorial? So we recall back what is the definition of n factorial. If n is a positive integer, then n factorial is given by n multiplied with the previous value, which is n minus 1, and then continue with minus 2, minus 1, minus 3, and then so on. The last term should be 1. For example, we have 5 factorial. So this should be 5 multiplied with, what is the previous value of 5? Real number 4, and then 3, 2, and then 1. And then how about definition of a binomial coefficient? So this n choose r. Let n and r be whole number with n more than or equal to r. Okay, so n should be greater than r. Then n choose r is equal to n factorial divided with n minus r factorial r factorial. Let's do some example 8. So 5 choose 2. What is 5 choose 2? By using the formula, the definition of binomial coefficient, so it will be n factorial, which is 5 factorial divided with n minus r. So our r is 2. So 5 minus 2 factorial multiplied with r, which is equal to 2. This is our n, this is our r. So we get the answer as 10. And then the next question, show that n choose 2 equal to n multiplied with n minus 1 over 2. So we have to apply the definition of binomial coefficient. So what is n choose 2? N choose 2 directly by using formula will be n factorial divided with n minus 2 factorial and then 2 factorial. So what is it that we can do so that we can simplify into this form? So what is n factorial? N factorial can be represented as n multiplied with n minus 1 multiplied with n minus 2 and so on. So n minus 2 and so on is actually n minus 2 factorial. That's why we can, yes, we can cancel out this n minus 2 factorial or the numerator with the denominator part. So what we have as the result is n multiplied with n minus 1 divided by 2 factorial. So what is 2 factorial? 2 multiplied by 1, which is equal to 2. So we have the result n multiplied by n minus 1 divided by 2. Okay, I think that's all for this lecture. So we are going to continue about the binomial expansion on the lecture 3. Thank you. Please do the exercises in the tutorial.